All right, let's dive right in. Today, we're tackling a concept that is genuinely mind-bending. We're going to explore the hidden connection between the very structure of reality and, the flow of time itself. It's a journey that's going to take us from some pretty big philosophical ideas right down to the fundamental bits and bytes that might just be encoding our entire universe. So this is the whole game right here. Our entire explainer is basically built around cracking this one simple-sounding paradox. I mean, it sounds impossible, doesn't it? How can the unchanging structure of everything, the logos, also be the source of all its constant change and flow? That is the core mystery we are going to unravel together. Okay, so what are we even talking about here? On one side, you've got time. That's the world we all live in, right? The constant motion, the feeling of change, one moment flowing into the next. But on the other side, there's this thing called logos, and that's the eternal, unchanging stuff, the underlying patterns, the laws of physics, the mathematical structures that hold the universe together. They really do seem like total opposites. So where on earth could they possibly meet? So, how do we build a bridge between this world of constant change and the world of eternal patterns? Well, our first big clue is a concept called the frame. This is the place, the bridge, where these two seemingly separate worlds are actually forced to interact. Think of it like this. Logos is the timeless blueprint of reality, and time is the ongoing construction project. A frame, then, is just a single, frozen snapshot of that construction. For just one instant, the eternal laws of the blueprint are perfectly captured in a temporary moment. It's the exact point where the pattern meets the present. The movie analogy makes this super clear. A film isn't actually moving, right? It's just a long strip of static pictures, one after another. Each individual picture on that strip, that's pure structure. That's logos at rest. But when you run them in sequence fast enough, you create the experience of motion, of change. You create time. This shows us exactly how logos, when you set it in motion, literally becomes time. Okay, so the frame is where time and logos meet up. But inside that frame, everything is still moving around, right? To really unify them, to find where they're the same thing, we need to find something that doesn't change at all. We need to find an anchor point, right at the very center of it all. And this is where we start the hunt for an invariant. In math and physics, an invariant is something that stays perfectly constant, even when everything around it is being twisted, rotated, or transformed. If we can just find an invariant point inside the frame, we might find the spot where time and logos aren't just meeting, but are, actually the same thing. And guess what? That anchor point totally exists. It's called the centroid. It's the geometric center of all the points in a frame. You can think of it like the system's center of gravity. Now here's the magic. You can spin the frame, flip it, look at it from any angle you want, but that geometric center point, it does not move. It's the invariant we've been looking for. And this is the big aha moment. If the frame is where time and logos meet, the centroid is where they become one. It's a single point of pure eternal structure, that's logos, and it exists inside a temporal frame, but it's completely immune to the flow. It's the still point in a turning world. You could even call it the eternal now. So, we've found an invariant inside a single frame. That's huge. But what about all the frames, all the possibilities? We're going to take one last step now to find the ultimate, the final, the all-encompassing invariant. So yeah, this is the big question, isn't it? We've been climbing this ladder of invariants, from the frame to the centroid. But is there one single thing that holds the blueprint for every possible frame, every possible centroid, every single state the system could ever be in? What is the one thing that contains all the others? And the answer, it's almost ridiculously simple. It's the byte, a single, humble 8-bit byte. How is that even possible? Well, it's through this incredibly clever process of information density called bit packing. Imagine a byte's 8 bits. Instead of using them all to represent one number, this system just slices them up. Maybe the first 3 bits define the frame number, the next 3 define a geometric point, and the last 2 act as a control code. The same 8 bits at the same time are encoding multiple separate layers of reality, both a moment in time and a position in the structure. So what does this mean? It means the byte isn't just data about reality, it is a complete, self-contained little universe, a concept some philosophers call a monad. It simultaneously encodes time, which is the flow between frames, and logos, the structure of points within them. It even encodes the agent, the position from which reality is being experienced. The whole distinction just collapses. The byte is the final invariant because it holds all the others. Time and logos are just two different ways of reading the same 8 bits. It's wild.
Now, I know this might all be sounding like some really out there philosophy, but stick with me, because understanding this unity between time and structure has some seriously powerful, real-world consequences.
Let's start with something like data compression. By getting to the underlying geometry of information, we can get some staggering compression ratios. This 100-to-1 figure you see here isn't just a theory. It represents the very real possibility of turning a massive 100-gigabyte codebase into just 1 gigabyte. How does that work? It's a process called geometric deduplication. Instead of just reading the words in a computer program, the system analyzes its underlying logical shape. Imagine 2 different chefs writing down a recipe for a cake. They use different words, different phrasing, but the steps: mix the dry ingredients, add the wet, bake. That structure is identical. The system sees that shared geometric form and only stores that core structure once. It's a totally different way to think about data.
And the implications for time itself are, frankly, even more profound. Right now, our best clocks are atomic clocks, and we use them to measure time, but they can drift and get out of sync. This framework suggests we don't need to measure time at all. We can generate it. A perfect, lossless sense of time can emerge directly from the predictable, deterministic way these geometric structures unfold. It's like a clockwork universe made of pure math.
This also completely changes the game for things like digital identity and security. See, modern cryptography is built on assumptions, like the assumption that a super long password is hard to guess. But a system of geometric identity is built on mathematical necessity. It is a simple, provable fact of geometry that a specific structure, the Fano plane, must have exactly 7 points and 7 lines. An identity system built on truths like that isn't based on how hard something is to guess, it's based on how reality itself is structured. It's just fundamentally more secure.
So we started with a paradox. How can time be motion and logos be stillness? And we found that there are really just 2 sides of the same coin. They meet in the frame, they become one in the centroid, and they are completely, perfectly encoded in the byte. Which leaves us with one last big thought to chew on. If an entire universe of structure, time, and even experience can be encapsulated in just 8 bits, what does that imply about the code that's running our own reality?